Hello, welcome to this video as well. Thank you very much for choosing us to watch this video and then so that we can continue the concept on sets. Last time we talked about, I use a word called upset, right? So when we are talking about set numbers, sets, right? These are numbers that they are not rational. Yes. So when you say rational numbers, these are, so let's simply think of them as the number that we easily handle. Something like um 2, 3, 4, -4, -5, 3/4. Those are rational numbers that we like. There's a ration, like there's kind of how do I say it? We are used to them. Yes, they make sense to us. So like they are rational, right? So, but there are some other group of numbers, right, that we call them irrational numbers, like pi, 3.142, something, 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 something. It doesn't repeat, it doesn't end, it just be continuing like that. And then we also have this group of numbers that are like square root of -1. So one thing about set is that a negative number cannot stay under them, like under the umbrella of the square root. The negative number cannot stay there. So what happens is that whenever you have that case, that number is made to be an irrational number. So sets also, when we find the square root of 4, for example, we usually get -2 or 2. We usually have a number that is rational. Yes. So numbers like square root of 3, square root of 7, especially if you are finding square root of prime numbers, we say it's not going to give you whole numbers, right? So those that are not able to give us whole numbers, we tag them as being sets. So another word we can say that a number is set. We can say those numbers are irrational. So there's actually a way to kind of make them rational. That's what we are coming to do today. We are going to do division after multiplication, but before we do division, we need to learn how to rationalize um, sets. Rationalize meaning that bringing them from them being sets or irrational to rational. One tool that will help us there is multiplication of sets, which we learned in the previous video. So we see that in the previous video, when we do multiplication of sets, right, at the end of the day, we usually get, we mostly get another thing that is containing sets again. That cannot be further be simplified, so we leave them like that. So let's look at an example. We look at 2 minus root 3 multiplying 1 minus root 3. So let's do this expansion quickly. So 2 times 1, 2 times 1, then this 2 multiply this term -3, right, plus 2 times -root 3. And then this one will also multiply this one. We use a second expansion, that will be -root 3 multiplying 1, then plus, then the next one -root 3, -root 3 plus -root 3 multiplying -root 3. So 2 times 1 is 2, plus 2 times -root 3 is going to give us -2 root 3, plus the -root 3 times 1 is simply going to give us -root 3, plus this one, negative times negative will be positive. But we say that when the same root is multiplying the same root, the answer is just 3 in this case. So when we do that, group like terms 2 plus 3, which are like terms, they will give us 5. And then if you multiply, if you add, here we are doing addition. So but then first we need to remove the bracket. 2 root 3 minus root 3. So at the end of the day, we are doing, so -2, -1, because the roots are the same. You know that whenever there is nothing here, we say it's 1. So the outside can be manipulated or like interacted. So -2 and -1, that will give us -3 root 3. So this is the answer that we got finally after multiplying these two brackets. these two brackets. So at the end of the day, we still have a set something containing in the final answer. So there's still set element over there. But there are some group of multiplication that we can do to get actual a whole number. So if you watch the previous video, we solve a question that we had. We do the expansion, then at the end of the day we had 0. We read another multiplication, at the end we had 400 in the previous video. So at the end, after doing the multiplication and the expansion, the final answer we got is they don't contain set numbers, right? They are just direct numbers that you have. So doing this, making sure that when we do the multiplication, you have a number that is not containing set or that's not irrational, we make them rational. That process is called trying to rationalize it. Not rationalize it. And one powerful tool is the multiplication that will help us do that. Generally, there are, so you can be trying to be multiplying the numbers like one set with another with another. Sometimes you get set, sometimes we will not get set on and off, but we are sure of one particular process that will help us that in a way that when we are multiplying a set with another or expanding one set with another one, what happens is that we will still have we will always have a whole number or a rational number. So let's see how that one comes about. Let's say um let's remember this difference of two squares. I don't know that you've heard of it before, but don't worry, I'll just talk about it in a bit. Square root of a difference of two squares. This is just a concept in mathematics, generally in mathematics, that we use. For example, if you are having a plus b in one bracket, multiplying another a minus b, the result will just be a squared minus b squared. This is the difference of two squares generally in mathematics. So if you have a plus b and in the second one a minus b, so just as the minus and the plus are the one just switching and keeping the same position of a is beginning, b is ending, a is beginning, b is ending. So at the end of the day, if you have a pattern like that, then it's a difference of two squares. They are multiplying this one bracket, multiplying another bracket like this. Then you just simply do a squared minus b squared to simplify the process for you. So that's what we are going to use in handling this set. So we're trying to find the conjugate of sets. So finding the conjugate of set is simply find the other brackets that you need to multiply the other brackets that you need in order to multiply and have a rational number. Let's say we have square root of 2. Square root of 2 minus 1. So this is like this is a minus b, right? So if you have a minus b in the other bracket, in one bracket, for you to use the difference of 2 squared, you need to make sure that the other one is a plus b. So it means that the other bracket that we need to multiply this guy with is root 2, changing the minus to plus 1. So at the end of the day, we said the bottom is going to be a squared minus b squared. So the top one is our a squared. Our a is root 2. So root 2 squared minus our 1 squared. At the end of the day, 2 squared, root 2 squared is equal to 2, and then minus 1. So if you are finding the square root, if you square a set, right, you are going to get the number a. If you have a cubic root that we talked about in the first video and you cube it, you are going to get a. So if the square of a number, of a set number, right, is just going to give you what is under the bracket, square root of a. It is the same as square root of a times square root of a, which we discussed, and it's still going to be a. So root a all squared is going to be a. That's what we are seeing here. Root 2 all squared, the answer is just 2. 2 here, and then 1 squared is just going to give you 1. So at the end of the 2 minus 1 is 1. So you see that at the end of the day, when we multiply this thing, we are having a, when we do the multiplication, at the end of the day, we are just having a number, a rational number, which is 1. We know there's no set inside, right? So doing this process to get a whole number from a particular set, that's what we call rationalizing the set. We are trying to rationalize the set. The other component that we brought to multiply the first bracket so that we can have a whole number at the end of the day, or a rational number at the end of the day, this component is called the conjugate of a set. So this is the conjugate. This is the conjugate, conjugate of our set. So for example, so we ask what the conjugate of root 5. So 3 minus root 5. So the conjugate of 3 minus root 5 is simply going to be 3 plus root 5. So we are just trying to change the plus to minus. So when you multiply these two at the end of the day, you multiply 3 minus root 5. You multiply it with 3 plus root 5. What are you going to get? We see it's going to be a squared minus b. Our a here in this case is 3. 3 squared minus our b is what? Root 5 all squared. So 3 squared is 9. We say if you square a rational number like that, we are going to just have 5. So 9 minus 5 is 4. So we see that at the end of the day, we have a whole number or we have a rational number at the end of the day. There's no set in the result, in the answer. So the partner bracket that we bring in order to multiply our bracket, our first set, in order to have a whole number at the end of the day, that's what we call the conjugate of a set. Let's solve few examples to solidify this concept. Yeah, that's our conjugate of sets, right? We are just trying to bring um that partner that we use to multiply the particular set so that we can have a whole number without a set inside the result at the end of the day. That's what we do. Let's see what we have here. um Conjugate of a set, conjugate of a set. Yeah, so let's another example. Let's find the conjugate of the following. So 2 minus root 3, 5 minus root 6, negative 4 minus 5 root 3. Yes, let's find the conjugate of these ones. So the conjugate of this guy, right? The conjugate of this guy. Yes, conjugate is like that other bracket. So you just imagine this one is already in brackets, but they won't give it to you in brackets, right? And no one will ask you to just find this conjugate. It's a concept that we use to do the division, so we need it. So 2 minus root 5, 2 minus root 3, sorry. If you find the conjugate of this, the conjugate of this is just try to find change the middle, change the middle sign. If it is plus, change it to minus. If it's minus, change it to plus. That's all. So I'm going to, at the end of the day, we have 2 plus root 3. This is the conjugate of this guy. So if you multiply these two by this, so now let's eliminate this guy, the conjugate of this guy. So the question is find the conjugate of this set. The conjugate of this set is this. That's the answer. But I'm just going ahead to just multiply so that we confirm that we are going to have a whole number at the end of the day. So it's like a minus b multiplying b minus c. At the end of the day, it's just a squared minus b squared. A squared, which is a, 2 squared minus the b is root 3. Root 3 squared. At the end of the day, square root 2 squared is 4 minus 3 root 3 squared is 3, because we said if you just square a set, you are going to have 4 minus 3 is 1. But at the end of the day, we just have 1. There's no set again inside. So yeah, so this is the conjugate of this. So for the next one, I hope you the conjugate of this one will just be 5 plus root 6. So you can try it on your own and finish and see which whole number you get. And you also realize that there is no whole number that we see at the end of the day. So this one, there is minus at the front and minus in the, over here. Remember what I said. To find the conjugate of the set, change the middle sign. The middle one between the negative 4 is here and then 5 root 3 is here. So the middle sign, which is the negative before the 5. So that's how you get. So we have negative 4 plus 5 root 3. So this is the conjugate of this guy. So this is the conjugate of this set. So yeah, I knew before bringing this minus here, so that you just have um, a simple way of getting a whole number. So conjugate of set, this is the concept. Just if they come in expansion, sometimes they may not come like this. Sometimes we may not need them like this. This is like something minus something, something plus something, right? But sometimes they will just come like that, like set. The set itself, there's nothing minus, there's nothing plus. We don't need anything, so we just have square root of 2. What's the conjugate of square root of 2? The conjugate of square root of 2, the answer is still the conjugate of this guy is still this guy, right? So if you do this, square root of 2 times square root of 2 is the same as square root of 2 all squared. Then you have 2. Yeah, so at the end you have a whole number. But let me prove to you why it is true. It is this following the same pattern, right? So if you understand the previous one, if you have square root of 2, the conjugate is still the square root of 2. Why? This is what happens. So if you have square root of 2, right? Square root of 2 alone. Let me clean this one. Let me this one. So square root of 2 alone can be written as square root of 2 minus 0 or plus 0. Let me do plus 0, or it can be minus 0. You don't care, because plus 0 there, we don't even write it, right? So to find the conjugate of what we did, if this is your a and b is your 0, or the conjugate will be what? Root 2, just change the middle sign, minus 0. That's what's happening. So if you are multiplying these two, together, what do you have at the end of the day? You have root 2 plus 0 multiplying root 2 minus 0. So if you do that, we say a squared minus b squared. Our a is root 2, right? It's going to be have root 2 to the power 2 minus 0 to the power 2. So it's going to just give you root 2 squared minus 0, so which is 2, because this guy will just give you 2. So 2 minus 0, 2 minus 0, and 2 minus 0 is just 2. That's why it was like that. So it's following the same thing. So if you just have what is the conjugate of root 3, basically the conjugate will just be still be root 3. But because the sign is the one that change, plus and minus that change between them. But because the plus is not here, we are assuming that 0 is there. So because 3 minus 0 anything, we just give you the same thing. So that's what same thing that is happening. So if you just have a root like that, then fine. The conjugate is itself. But if you're having square root of 3 minus, let me write it, square root of 3 minus 1, the conjugate of this will just be root 3 plus 1. Just change the middle sign. So if you have negative 2 minus root 2, the conjugate of this will be negative 2 plus root 2. Remember, we are just changing the middle guy between the two numbers. Don't go and change this one. Don't go and change this one. So this is the conjugate of set. So this is the concept around sets, right? The conjugate of finding the conjugate of a set. We'll use this in the next video to look at how to do divisions using set. Thank you very much, and see you in the next video.